Hello everyone, we will go over lecture 27, sample means. I'm your instructor, Miss Laura Lowe. We are in module 10. We talk about normal distribution and introduce the central limit theorems in lecture 26. So in today's lecture, we will continue to talk about more about the distribution of the sample average. Then we will have more complete definition and introduce application about the central limit theorem. So then in the final lecture in module 10, we will see how to construct the confidence interval and how to choose the sample size for the experiment. So let's start our 27 lecture. At the beginning, let's quickly recap what we learned the central limit theorem from the previous lecture. So remember, when we talk about the central limit theorem, we use our sample average. The central limit theorem describes how the normal distribution, which we say a bell-shaped curve, well-balanced and smooth curve, is connected to random sample average. We care about sample average because sample average can give us the estimation about the population average. And also remember, in our previous lecture, we show you when we got sample average for 10,000 times, then we see the empirical distribution. They look like a normal distribution very well. So that's we come out the central limit theorem. The central limit theorem, the most important thing is when we take the sample size, this should be large and draw at random with replacement. So that means every time we draw one sample, but we put it back and draw again. This one, remember when we say the sample is drawn with replacement, but if your population size is really big, then you draw at random with replacement or without replacement won't have much difference. But, right, definition we told you, when we have the central limit theorem we want to apply on that, we draw the sample data from the population, make sure the sample data is large as possible, then you draw at random with replacement. Then, regardless of the distribution of the population, the probability distribution of the sample average is roughly to be normal distribution. We know in our example, we're using when we get the sample data, we try to find the average. But this theorem actually can apply on median as well, because you know for the normal distribution, when we have the center, that can be either median and the average. Okay, so but here we're using the average for the example. So the distribution for our sample average is roughly to be normal distribution is very important because as we introduced last lecture, normal distribution is the ideal bell-shaped curve. Is smooth and almost all the data within average plus minus 3 times standard deviation. Remember that's like 99 point something. And also even not 99 point something, when we have the normal distribution, the average plus minus 2 times standard deviation, all the data actually cover under 95%. So that's why here, normal distribution things we have very important characteristic we can use. So that's why here, when we struct the distribution of the sample average, kind of give us a lot of information. So that's back to see the distribution of the sample average. The first thing, we will think about why there is a distribution. Of course, because in our example last week, we did show the sample data many times. So that's we come out the distribution. But think about, if you only have one random sample, you only have one average, right? So that's how the distribution came from. The reason is, even you have one random sample, it only has exact one average. But this sample could have come out differently. For example, I want to ask everyone in the class do the sample on 100 DVC students you random survey from. So then you ask them what their age is. So then we got the average. But here we have like almost 20,000 students in DVC. So then, for example, we have 40 students in our class. I ask you guys, everyone go to find 100 students from DVC to get the average for their age. So everyone come back, will have different average, right? So actually, yeah, we have 40 students to find 40 sample. It possibly we have 40 different average. So that's mean even we have one random sample, we come out one average, but different sample, they have come out differently. So then the sample average might have been different. Yeah, so very likely 40 student, 40 sample, we may have 40 different average. So there are many possible sample average. So that's the reason we have the distribution, right? Because from the last lecture, we do the sample 10,000 times. We got a 10,000 times, we got the sample size. Each time is for 400. So then we have all different sample average. So that's why we have the distribution. So that's why distribution of the sample average is imagine you have all possible random samples of the same size. Be careful, we need to get the same size so that we can compare with. So we got the same size as yours. So there are a lot of them. Okay, so I have 2 data science class. So each class have 40 students. So I ask all of you to go to find the sample size, to get a sample, then find the average. Then come back, you guys can give me, possibly we will have 80 different average. So each sample has one average. So the distribution of the sample average, it come out is the distribution of the average of all the possible samples. So that's, again, we're back to see our distribution. So we're back to see our example from last lecture, right? We're still using the United Airlines data. Yeah, sorry, because I just started the file, so that's why earlier this cell didn't run correctly. So that's why there's error earlier. So that's our United data. So let's see here, that's the original, the population distribution for the delay. Yeah, that's very right skewed distribution. Okay, so then remember, for each sample, we write a function called one sample mean. So passing the sample size, we will return you from this sample size what is the mean for all the data here. So then, since we need to do the simulation to find the distribution, so you provide the sample size, we will run 10,000 times for this random sample. Okay, so the same thing, that's redo these 2 functions. So then the first thing, let's see here. If we run, the sample size is 400 as we did from the previous lecture. Okay, so but we do 10,000 times. So that's why we see here, you can see they are not exact perfect normal distribution, but they do have the shape. We can say they have the bell curve. Okay, so that's why here they're not complete symmetric, but symmetric well. Okay, so we can roughly to draw the bell curve like this. So that's why, of course, you will see we will guess the average is between these 2 highest bar. So that's right, that's about 12, 16 and 18, so that's 17. So that's about 16.5 around that. Okay, so that's we got our distribution, right? So you see this distribution actually is 10,000 sample to make the distribution. But like earlier we say, when we draw the sample with replacement, this sample is what? This population size is 13,825. So each time you do the sample to get a random sample, you got 400 sample from that, right? So that's me. And also we do with replacement. So that's why each time you do the sample data, you have how many combination? So that's why all the combination actually is because we put it back with replacement. So that's why it will be 13,825 row we power to 400 times. So here, just from here, the 10,000 possibility. Okay, so then actually you have so many different combinations. So that's the reason you have many distribution, then they cannot become the distribution of the sample average close to the normal distribution. Right, from the demo, we can show you the distribution of the sample average close to the normal distribution. And also, we are not only show you 400, right? From last lecture, we show you 100, 400, 1,000. So, and also we see if your sample size is bigger. Actually, start from 100, they all have similar to the bell shape. But the most important thing is, what is bell shape? So what those bell shape for the distribution? So specifying the distribution, the most important thing we suppose the random sample is large. We have seen that this distribution of the sample average is roughly bell-shaped. Start from sample size 100, 400, 1,000. They're all close to the bell shape. The important question we want to ask, where is the center of the bell curve? Because if that's normal distribution, if we can find that center, we find the average. And also how wide is the bell curve is. If you remember at the end of last lecture video, we show you from 100 sample size, 400 sample size, 1,000 sample size, they all look like the bell shape, but also we can see the interval on the width for the bell curve actually is quite different. Okay, so that's why here, let's go back to see our demo. So here in our demo, that's mark our center. So we still have our 400 sample. Yeah, we do 400 times. We have this result. We do each time we do the sample size 400. Yeah, we simulate 10. We do the average. We do the sampling 10,000 times. So then here we see the distribution. You see actually here we run again because compared to earlier, you run one time. The sample size is 400. So then we do 10,000 times. But just like earlier we said, you have so many combinations. That's why even we rerun again. So here actually we run again, right? So that's why you can see the second distribution, they are slightly different from the previous one, right? So previous one, actually these two bars, they are kind of similar height. Okay, but no matter which one, they still got a normal distribution. And also still we can see, because that's why you see the height here. So we kind of cannot really say this one is the highest one, kind of is in between, right? So that's why we try to find somewhere in between. So then you can see here is 15, here is 17.5. So again, if we want to draw the curve, okay, so then maybe here is our center. Okay, so our center, right, so is about 16 that's 15, yeah, 16.5 something. Okay, so that's here. And also we show you the population average is 16.6, around 66. Yeah, so then not only they are the bell curve, but also the center is pretty close to the population center. Okay, so the most important thing, what that mean for us? So we continue discuss in the next video.